So today our topic is derivation of Dalton's law of partial pressure. Dalton's law of partial pressure. As yesterday, and we discussed about the Dalton's law of partial pressure. What was that? What was the Dalton's law of partial pressure? So today we will discuss about the derivation of Dalton's law of partial pressure. Suppose here what was the equation? That is a PV is equals to nRT. That is the equation of ideal gas, right? So suppose here we are having number one gas is A and one container. Here is pressure meter, and number two gas is that is B. Suppose B, right? When we mix these gases, it will be the AB, right? AB. These both are non-reacting gases. What was the Dalton's law of pressure? That non-reacting gases, mixture of non-reacting gases, they call the partial individual pressure of any non-reacting gas known as a partial pressure. So AB, it will be the gas. So we can see that total pressure, suppose that here the 1 atm pressure of A and 1 atm pressure of B, so total pressure will be 2 atm. So we can say that PT, which means total pressure will be equal to the pressure of A plus pressure of B, right? If there is any gas, suppose that CO2 or O2, so we can write total pressure will be equals to the pressure of oxygen, pressure of CO2. So that is a total pressure is equals to the PA plus PP, right? Now suppose for gas A, right? For gas A, here we are having PV is equals to nRT. For gas A, PA, because we are finding for the A gas A, Na and RT, right? So PAV NART. Suppose that this is equation number 1. Now for gas B, PBV is equals to NBRT, right? Because this is a gas for gas B. So this will be the equation number 2. Now if we are finding about the gas A, here we can write PTV is equals to the NT and RT. How? If we talk about the total pressure, here we will write T because of the total. Here we were having gases A and B. Here we are finding about the total. Suppose that this is a third equation, that is a of the total. Now if we are finding about the gas A, so divide equation number 1 and 3, because for gas A there is a one equation, right? So divide equation 1. What is the equation number 1? That is the PAV is equals to the NART upon PTV upon NT and RT, right? You can see it is the third equation. V cancel with V, RT cancel with RT. So here is remain that PA upon PT is equals to the NA upon NT, right? Here we are having Na upon NT, right? This is called the mole fraction. So the mole fraction is equals to the xi, which is x. This is called the xi. This is the mole fraction. Na upon Nt is equals to the mole fraction. The symbol of mole fraction is xi, which is x. So here we are finding about the gas A. So here we will write xi A, xa, right? So we can write here PA upon PT is equal to the XA, which is xi A. So here we can write pressure of A is equal to the xi A into PT. So here we can find the partial pressure of gas A, right? Now if we want to find about the B gas, for gas B, now we will divide the equation number 2 and equation number 3. What is the equation number 2? PBV is equals to NBRT upon, what was the equation number 3? That was the PTV is equals to the NTRT. RT cancels RT, V cancels V. PB upon PT is equals to the NB upon NT. Now this is more fraction, that will be the xi b, because here we are finding about the b, right? So xi b, so PB is equals to the PT is equals to the xi b. Here this is dividing, here we will multiply this. So PB is equals to the xi b into PT. So here we can find the partial pressure of the gas B. Here I am supposing about the gas B or A gas. If in question we are having given CO2 gas, any gas, O2 gas, nitrogen gas, we can put here that one, right? If you are having three gases, we can write B, A gas, B gas, and C. We can also find about the C gas. So three gases, how many gases we are having? So we can find about the partial pressure of that gases. Here I have found about the A and B, right? So this was a partial pressure, derivation of the partial pressure.